Hello students, welcome back to my YouTube channel. Today I will discuss a very important question taken from simple harmonic motion. This question asked in IITG 2009. In this question basically we have to calculate amplitude. As we know that in the case of simple harmonic motion, amplitude is the maximum distance covered by the particle from mean position to extreme position. Now this question is the mass capital M shown in the figure. This is the mass of the block, correct? Oscillates in simple harmonic motion. Oscillates means that particles goes back, forth, yeah, up, down motion. Oscillates in simple harmonic motion with amplitude capital A. This is the amplitude of particle. The amplitude of point P each. Now, we have to calculate amplitude of particle P. This is the P. We have two springs. This is the spring first and this is the second. And this is capital M. Now, if M displaced, suppose x towards this x, then elongation in this and this. Elongation in this, suppose that x2, and elongation in x1, k1 is x1. And finally, particle displace at here. The values of this is equal to combination of both expansion, correct? Means that this is the original position of the particle. This is the original position of the particle. This is the P. Now, this particle comes at this. Suppose that this particle comes at this. This is the P dash. And finally, this M comes here. Comes here, okay? The P comes here, that is X. This is the X, okay? Now, this is like more compression, correct? This is the P dash, this is the more compression. And this was P. So now, P displaced X distance and becomes P dash. This is K2 and this is K1. We can write X1 compression in a spring. X1 is the compression in a spring K1 and X2 is the compression in a spring K2. So we can write X1 plus X2 is equal to X or this is A. Amplitude A means that particle, this is the mean position and this is the extreme position. This is extreme position. As we know, in SHM, this is the mean position where x equal to 0, and this is the extreme position. This point is extreme position. The distance between mean position and extreme position is called amplitude. Correct? So now, we can write x1 plus x2 equal to x1 plus x2 equal to A. This is the A. Any doubt? Okay. Now, if a spring equal to K into X, so a spring in first is equal to a spring in second. In case of series, this is the K1X and K2X. This is the K1X and K1X1 and this is the K2X2. This is the K2X2 and this is the K1X1. This is equation number first and this is equation number second. Correct? X2 equal to, now, from first and second. This is the X2. X2 is equal to K1X1 divided by K2. Putting the value of X2 in this. So this is the X1 plus K1X1 divided by K2 equal to A. Any doubt? Now we have to calculate X1. Position of P. This is the X1. So X1 equal to K2 into A divided by K1 plus K2. This is the amplitude of point P. In case of amplitude, this is amplitude of P1. This is the answer. So answer will be D. Please subscribe to my YouTube channel share the video and like it. Thank you so much.